We are going to look at how do you simplify radical expressions. And by the way, radical is a fancy term for a square root symbol. It can also represent like cube roots or something to the fourth or the fifth root. So it's just a general term. So you could say we're simplifying square root expressions on this particular worksheet. So before I do this, let me review that you should know your perfect squares. 1 is a perfect square because 1 times 1 is 1, but we really don't care about 1 right now. But 4 is a perfect square, 9, I'm doing this real quick, 16, 25, 36, and I would suggest you write these down on the side of your paper so they're real nice and handy. Most people know these like mentally, they're really good at this. We even know 12 times 12 is 144, so that's a perfect square. You might even know 13 times 13 or 14 times 14. Here's 15 times 15. And then this last one is 16 times 16. So just in case you don't remember that one, okay? So there's some perfect squares. Why are they perfect? Because if I would take the square root of 1, for example, if I would take the square root of 64, I get out a nice whole number. I don't get out a decimal or anything yuck. Okay, so these are all perfect. All right, now, also some things that are perfect are, think about this, x times x. Remember when you multiply, that looks like x minus x because my pen blurred, but x times x, remember when you multiply, you add your exponents. That would be x squared. And if I took x squared times x squared, that would give me x to the fourth. If I took x to the third times x to the third, I would get x to the sixth. Let's do a couple more here. Watch this. X to the fifth. I know I skipped one. Times x to the fifth is x to the 10th. Let's do this one. X to the 10th times x to the 10th is x to the 20th. These are all perfect squares. What do you notice about them? All of the exponents are even, okay? So if I would take the square root of x to the 6th, 6 is not a perfect square, but 6 is an exponent here. X to the 6th is a perfect square. It would be x to the 3rd. Why? Because x to the 3rd times x to the 3rd is x to the 6th. Okay? So as long as these are even, life is good. All right? What you're practicing on this worksheet right here, and I did a few of these in class, but let me do just a few more, is simplifying these that are not perfect. So what you're going to want to do right here is find the biggest perfect square that will go into this. So for example, 25 will go into 125 5 times. So what they have to do is they have to show me one step. So you're going to have to write 25 times 5, and you can write times n or whatever, okay? I chose 25 because he's perfect. Then what they can do is they can either underline or circle the perfect square. So notice this is an odd exponent. That's a 1 if you don't see anything. So he is not perfect. So this is not politically correct, but this is what I tell them because it helps them remember. If they're perfect, they can come outside, okay? Otherwise, they have to stay inside. When you take the square root of 25 out, he becomes 5. And whatever's not perfect has to stay under the radical or under the square root symbol. So that is that answer right there, okay? Now, 216 may not be one you know. So this is what I told them on their calculator. Mess around until you find something that will go in there evenly. And I'm talking about one of these perfect squares right here. So believe it or not, 36 will go in that. Hit that in your calculator. 216 divided by 36, and you're going to find it goes in there 6 times. So I'm going to write it like this. 36 times 6 is 216. Why did I choose 36? Because he's perfect. I let it up perfect. He's perfect, and that's the only thing perfect, so he can come outside. When you take this guy out, he becomes a 6, and then whatever's left has to stay inside. Now, here's what's cool. That's your answer. Let's say you didn't find the biggest one, okay? Let's say you tried 4, and 4 does go in there. So let's say you're like, oh, I'm going to do 4, and 4 goes into 216. How many times does that go in there? 54 times, okay? So I could do it like that, and I would pull him out. And so I'd have 2 square roots of 54v. Now I might look in there and be like, oh, I wonder if there's another perfect square in there. So hopefully you know 9 goes in there, and 9's perfect. So I'm like, ooh, okay, I'm gonna do this again. I know 9 times 6 is 54, and he's perfect. So I can pull this 9 out. When you pull the 9 out, the square root of 9 is 3. And when you pull them out, you're multiplying these. So notice 3 times 2 is 6. What's not perfect has to stay under there. So you still get the same answer. Maybe it took you an extra step, but you're still there. Okay, let's look at this one, 512. Here's what's crazy. You're going to want to mess around until you find the perfect square. Here's what's crazy, because I've done this for so long. I know 256 goes in there, and 256 is a perfect square. If it takes you several tries to find it, that's okay. And this is an even exponent, so I also know he's perfect, so I don't have to do anything with him. You have to show this metal style, okay? So underline or circle what's perfect. If they're perfect, they can come outside. The square root of this is 16. The square root of k squared is k. He's not perfect. He has to stay underneath that radical sign. So that would be your final answer. All right, now let's look at this one. Look, same answer, 512. And that's one thing I like is if you don't know these, once you figure out one, it helps you with some of the others. So we already learned 256 times 2. But guess what? I'm going to go ahead and show my work. It doesn't take but 1 second. This is odd. He is not perfect. But let me give you a hint of what you can do. If you have an odd exponent, just lower it by 1. So I'm going to write it as m squared times m. Notice if you multiply these together, you get m to the third. Just like if you multiply these together, you get 512. Okay, that's all underneath that big square root symbol. I'm going to underline my perfect ones. Remember, if it has an even exponent, he's perfect. So the square root of this is 16. The square root of m squared is m, because m times m is m squared. And then whatever you didn't either circle or underline, like this little 2 here and this little m here, he has to stay underneath the radicals, just like that. So that is your answer. Now, let's find some that have several variables in them. Trying to find a good one here. Definitely not one that's extra credit. That would just be wrong. How about this one? And I may have done this one in class, number 26, but let's do this one, okay? These are not any more difficult, and by the time you get here, you're so going to be ready. Is there a perfect square in 24? And I'd be like, yeah, 4. 4 times 6 is 24. Now, somebody in class told me 8 times 3, and I was like, great, 8 times 3 is 24, but neither 8 nor 3 are perfect. Okay, so that doesn't help me. You're wanting to find a perfect factor, okay? Even exponent, so he's already perfect. Leave him alone. He's even, he's perfect. Odd, so I'm going to lower him by 1 and then write the c, because c squared times c is c to the third. I'm going to underline everything that's perfect. Remember, if they have even exponents, they're perfect. Okay, so look what you've got here. When I pull the 4 out, he becomes a 2. Okay, and we're going to be multiplying those together. The square root of a to the 4th is a squared. The square root of b squared is b. The square root of c squared is c. And then whatever's left has to stay under there. Well, there's a 6, and I forgot to underline him, didn't I? There's a 6 and there's a c that have to stay under there. So my final answer right here is -6, because you multiply those two together. A squared bc square roots of 6c. Crazy, I tell ya. Okay, try this. Have a little fun.